Okay, let's discuss let's discuss another microwave path parameter called the surface refractivity. Okay? So yung EM waves natin is don't travel exactly at a straight line path, no. Of course, in a line of sight propagation manner. So dahil meron tayong first reason, no, kung bakit, it's because of the Earth's curvature, no. Yung Earth kasi natin is hindi naman talaga actually flat yan. Not unless flat earther believer kayo. Yun yung papaniwalaan nyo. Of course, kung hindi naman, yung Earth natin is curved, no. Yung EM waves natin is nagtatravel lang siya, no, in guide with the curvature of the Earth. That's the first reason kung bakit, no. The second is yung atmosphere natin mayroong tinatawag na refractive index. No? That varies depending on the altitude called the surface refractivity. Okay? Sir, di ba yung refractive index sa Snell's law lang yan or dun sa optics lang yun pag tumama yung isang light dun sa object? Okay? Depende dun sa refractive index ng object, no? Depende rin yung angle of refraction niya. So, sa atmosphere meron din, no? But this time, hindi naman ilaw or light yung pinag-uusapan natin. Pinag-uusapan naman natin dito is yung pag-bend ng EM wave. Okay? So, as the altitude increases, yung effect ng bending is mas mataas din. Okay? Of course, pag mas mababa, yung EM wave is hindi siya nagbe-bend. No? Nag-travel lang siya in guide with the Earth's curvature. Sinusundan niya lang yung curvature ng Earth. Okay? That's why yung mga microwave tower na nakikita nyo, no, wala naman kayo makikita ang microwave tower na kasing taas ng isang bundok, no, walang ganun, no. Commonly less than 300 meters lang yan in height. So that maiwasan natin yung bending ng EM wave kasi ayaw natin nun eh. Okay? So, yan yung reason kung bakit less than 300, no. Normally parang mga 100 meters lang to 200 meters yung height ng mga microwave tower na makikita nyo. Okay? So, next path parameter is called the effective Earth's radius. So, in order, no, to maintain the line of sight propagation between the two microwave towers, despite of this bending of EM waves, no, due to the atmospheric refractivity, okay, kailangan natin i-modify yung Earth's radius based on the certain atmospheric condition. Okay. Baka nagtataka kayo, no, sir, babaguhin natin yung radius ng mundo, no? Hindi, no. Meron lang tayong gagamiting equation, no, in order to calculate para malaman natin, no, kung ano ba yung tamang Earth's radius na hindi magbe-bend yung EM wave natin. Ganun lang yung ibig niya sabihin. No? Papakita ko na lang sa inyo yung equation. Okay, ang tawag doon is called the effective Earth's radius. So, ito yung equation na gagamitin natin, no, for the effective Earth's radius. So, RE in kilometer is equals to RO. Yung RO is yung true Earth's radius, which is 6,370 kilometer. I think yung number na yan is nasa calculator, no? If I'm not mistaken. Nasa constant ata na calculator. No? Divided by 1 minus 0.04665 e to the 0.005577 ns. Yung ns is yung nasa baba na equation. No? Ns is equals to NO, sea level refractivity yung NO, times e to the negative 0.1057 Hs. Yung Hs is the height of the potential height in kilometer. So, let's have an example na para mas maintindihan nyo. So, punta tayo sa kabila. So, determine the surface refractivity for a potential height, not potential height, no, potential microwave site pala, that has 250 meters above sea level with a sea level refractivity of 312 and also calculate the effective Earth's radius. So, hindi natin masosolve si effective Earth's radius. It's because wala tayong value ng NS. Okay, so kailangan muna natin hanapin si surface refractivity. So, yung equation for surface refractivity is equals to NO. Binigay naman yung NO dito or yung sea level refractivity. 312 times e to the negative 0.1057 Hs, no? I think binigay dito 250 meter. So, dapat naka-kilometer, no? So, kailangan natin i-divide ng 1,000 okay, para maging dapat pala mali ako. Dapat pala ganito. So, 250 meter times 1 kilometer over 1,000 meter. Para makakancel si meter, ang matitira na lang kilometer. So, 250 divided by 1,000. Pasensya na kayo dun sa aso. Malakas ang tahol. Okay, so compute natin si surface refractivity times E to the negatives 0.1057 times 1,000 times 250. So, ang sagot ay 303.86. So, 303.86. Wala namang unit yan. Okay. So, ito yung NS. So, makukuha na natin yung effective Earth's radius. So, effective Earth's radius in kilometer is equals to 6,370 kilometer. O, pwede nyo na hindi ilagay yung kilometer. 1 minus 0.04665 e to the 0.005577 NS. Lagay ko na dito yung NS. 303.86. So, compute natin si RE. 6370. 1 minus 0.04665 E 0.005577 times 303.86. So, ang sagot ay 8,538.8 kilometer. Or pwedeng ganyan na rin. I-round off na lang pala natin into whole number. So, yan yung sagot. Okay, so ano pa bang hinahanap? I think wala na naman kasi yung surface refractivity nahanap na natin, NS, and yung effective Earth's radius itong 8539. Alright? So, balik tayo sa PowerPoint. I think tama naman. Tumama naman tayo sa sagot natin. Okay? So, next parameter is called the Earth Bulge and Earth Bulge Factor, or yung K. O yun yung Earth Bulge Factor. Okay? So, yung Earth Bulge is the curvature of the Earth's radius, no? Kumbaga parang ano to eh. Hindi naman siya, parang radius, kumbaga. Parang gano'n. Okay? So, ang formula natin for Earth Bulge is ito, no? Dalawa, in feet and in meter. So, in feet is equals to D1 in miles times D2 in miles divided by 1.5K. Yung K, dun sa libro, maraming formula, maraming values pala, hindi pala formula. 1, negative 1, infinity, no, and 0. Pero hindi naman masyadong lumalabas yung mga values na yun sa mga problems. Madalas, laging 4/3. Kaya 4/3 na lang yung nilagay ko, no, if normal atmospheric condition. Okay? Earth bulge in meter naman is equals to D1 in kilometer times D2 in kilometer divided by 12.75 times K. Okay, so let's have an example. Balik tayo dun sa software na ginagamit ko for writing, no, a solution. So, calculate the effective height of a 100 feet obstruction situated 10 miles from the receiving end of a 25-mile radio link for the following values of K. Yan pala, may binigay pang mga values ng K. So, effective height, no? Wala naman tayong binigay na effect. Wala namang formula pala na binigay na effective height. Pero yung effective height is equals to the earth bulge or yung EB plus yung height ng obstruction 100 feet. So mamaya i-drawing ko para mas clear sa inyo. So i-drawing natin yung scenario dito. Sabi dito, calculate effective height of a 100 feet obstruction. So merong radio link, merong transmitting antenna, merong receiving antenna. So, 25 mile. Yung total distance between the two towers. And meron daw 100 feet obstruction situated 10 miles from the receiving end. So, ito si receiver, ito si transmitter. So, 10 miles, siguro nandito yung 10 miles. Meron daw 100 feet. 100 feet. Okay, so, ang tinatanong is effective height. So, earth bulge, kunin natin yung earth bulge. So, ano bang mga units ng mga, I think naka-mile. So, ang gagamitin natin is yung earth bulge in feet. So, yung D1 is pwedeng 10 miles or pwedeng 25 minus 10 is 15 miles. Tama ba? So, alin man sa dalawang yan, wala namang problema kasi imumultiply naman natin silang dalawa. So, 10 miles times 15 divided by 1.5. Yung K is letter A. Yung letter A is K is equals to 4/3. So, 4/3. Okay, plus 100 feet. So, equals 10 times 15 minus 1.5 times 4/3 plus 100. So, 175 feet. Sana tama itong aking sagot. 175 feet. This is not earth bulge pala. Ito pala yung effective height. E sub H. So, for letter A, 175 feet. So, baba muna natin itong second problem. Letter B, ganun pa rin naman yung equation. Papatan lang natin ang value ng K. So, EH is equals to 10 times 15 divided by 1.5 times 4/3. Oops, hindi pala 4/3. Ano bang value ng K? 1/2 na pala. So, 1/2 plus 100 equals 1/2, 300 feet. Okay. So, letter C, E sub H equals 10, 15, 1.5, and then, ang value ng K natin is 5 halves or 2.5 plus 100, 5/2, 140 feet. So, 140 feet. Okay. So, tingnan natin kung tama yung ating sagot. Ayan. So, 140, 300, and 175. So, tama naman tayo. Okay? Okay. The next parameter is called the antenna height. So, antenna height is equals to, in feet, is equals to D1 times D2 in miles divided by 2. If in meters naman, yung D1 and D2 is in kilometers divided by 17. Okay? So, next, I think this is the last one, which is the radio range or the radio horizon. So, D in miles is equals to square root of 2HT plus square root of 2HR. Yung antenna height, both transmitter and receiver is naka-feet. If in kilometers naman, yung radio range, 4 times square root of HT plus 4 times square root of HR. In meters naman, yung height ng transmitter and the receiver tower. Okay? So, let's have an example. So, calculate the maximum range for a microwave link for which the antenna heights are 160 feet. So, kung mapapansin nyo yung mga problem dito sa comms is sobrang dadali lang. No? Hindi nyo kailangan ng analyzation na sobra. Okay? Hindi nyo kailangan ng counting ng critical thinking, no. Hindi katulad kasi ng math, sobrang kailangan mo ng analysis dun eh. So dito more on direct substitution lang. Okay? So D in miles or yung radio range is equals to the square root of 2 times 100. Pwede naman magkabaliktad yan. Times square root of 2, 60 times 60 feet. So, equals to square root of 2 times 100 plus square root of 2 times 60. So, ang sagot ay 25.1 miles. So, ito daw yung maximum radio horizon na mangyayari, no, pag yung antenna height ng transmitter and receiver ay 160 feet. Okay? So, madali lang, no? So, yun lamang muna for now, and i-run through nyo ulit tong mga diniscuss ko. And thank you for listening, and God bless.